Hi, it's Gianluca Ciccone. I'm gonna walk through my algorithm and show you how it works for the Monty Hall problem. So first, I take the classes that we were given. I turn the first few into arrays. Then for the doors, I have the properties, numbers, cars, and if it's opened. First function that I made is to set the doors. So they're all set to, they all are given a number. Then they're given, their is car property is set to false for all of them. And there is open is set to false also. Put that into an array. Then we randomly choose one of them to become a car by changing the is car property to true, so that later we could check to see if the one we chose was a car. Then for the first door picked, we randomly pick a door, when we store it. Then for the second door, because it has to not be the same door and not be a goat, we run a loop to randomly pick one, and if it's not the first door picked and it's not a car, we return that and keep it as the second door. Then for the final pick door, it's basically the same, but it's to see if it's the first door, and to make sure it's not the first door and make sure it's not the goat door. Then the randomize function here is so that when the contestant is up there and he has to choose whether he wants to switch to the last door or keep his original door, I just randomize that. So I randomize that, and then I see if the door chosen at the end after it's randomized is a car or not. If it's a car, we set the variable 1 to true, and if it's not a car, we set the variable 1 to false. And I made a function that just runs all my other functions in it so that it's easier at the end. Then we write the amount of games we want. We start a new statistics outside of the loop so that it can be changed and stored. Then we run a loop for the amount of games we have. And it runs the game, and it checks to see if the original door is the same as the random door chosen at the end. And if it's 1, I just put a number 1 to the array that holds games with same door 1. And it's the same for everything else. So random choice is not equal to door picked, but it's still 1. We push it to games with door changed 1, but just push the number 1. And I do that for all 4 of them so that, depending on the outcome of the game and if we win or not, it stores it in that value. And the reason it's a 1 is just because I needed a way to find the length of that array for the math later. Then we take the length of those arrays, and then we do the math, which is just, let's say for the percentage of games won when it's the same door, we take the length of the amount of games won, we divide that by the number of games won and the number of games lost, times that by 100 to get the percentage, and then we do the same for when it's changed. So we take the length of the changed games that we won, divided by the length of the changed games that we won and length of the changed games that we lost, because it's the total of, whether he changed them or not. Then we multiply that by 100. We just console log the output plus, percentage of games were won by not switching. And if we run the function or the code, we will get, it's almost always 33 and 66, which is a good sign, I'm pretty sure. And yeah, it works. We could even change the number up here. Let's see. It'll be a lot different if we do 100 games. Let's see. Yeah, 29 and 100, but not 171. The more numbers we add, the higher the numbers, the more consistent it becomes. And it's, most of the time 33 and 66. And yeah, that's it. That's how it works. That's how it's run, and the pseudocode file is over here. Thank you for watching, and yeah.